Here we're asked to find the determinant of a 3 by 3 matrix. So for this one, we're just going to kind of go ahead and use the standard formula of how we usually just use our cofactors and go across, say, the top row. So this is usually the default if you're asked to do a determinant, particularly for a 3 by 3 matrix. So what we're going to do is what's called the cofactor expansion. So we're going to, first of all, I like to just assign signs to everything. So it makes sort of a little checkerboard pattern here. The top left entry is always positive. And then we should get like a little checkerboard of pluses and minuses. So if we were to choose, for example, a different row or column, this would tell us which entries get positives and which ones get negatives attached to them. So you see the pluses and minuses alternate through up and down and left and right. So we're going to start with the 2, and the 2 is positive. And so what we do to figure out how we're going to go from here is we sort of eliminate the row and the column that has the 2 in it. And what that leaves for us is this resulting 2 by 2 matrix. And so we're going to break it down now to the determinant of just that resulting 2 by 2 matrix. So it'll look like this. And so what I'm going to go ahead and do now is get rid of that pink because it's sort of done for the 2. We have to go back to the full matrix to move on. And so now we are going to go to the next entry. So we make our way to the 0. It doesn't really matter if 0 is plus or minus, but just for the sake of consistency, I'm going to do a -0. And technically, I don't need to even consider what this is multiplied. But again, I just kind of want to make sure we can see where everything's going here. So I'm looking at the 0, and that's going to cancel the column and row that 0's in. And you can see that this leaves me with basically this sort of 2 by 2 leftover scraps that are going to form my 2 by 2 matrix. So that first column 1, 0, and the other column 5, 0 is what remains. And if I make my way over, the next thing I'm going to have is plus, and it is a -3. And I'm going to do something similar to get the corresponding matrix that goes with that. And so I'm working with that -3. I'm going to cancel out the column and the row that that's in. And it just leaves me with that corner square for my final 2 by 2 matrix. I get the 1, 2, and the 0, 3. All right, so again, notice the signs change. It's plus the first entry, minus the second entry, plus the third entry. But because the third entry is negative, it's still going to end up being negative. And so now what we do is just kind of go through and do those 2 by 2 calculations for the determinant. So I'm going to get 2. And then just if you recall how to do a 2 by 2, it's going to be 2 times 0. So A times D minus B times C. So that's 5 times 3. Minus 0. I don't have to do the next calculation. It's times 0. And then the last one will be -3 times 1 times 3 minus 2 times 0. And we just go ahead and work that out. So that'll be 2 times 0 minus 15 minus 3 times 3 minus 0. So I'm getting -30 plus 9. Sorry, minus 9. Right, yep. And so -39. And that would be my determinant. And to answer the question of whether or not this is invertible, since it's not equal to 0, it implies that it's invertible. So as long as it's non-zero, this will be an invertible matrix.